Hello everyone, in this video we are just going to learn to acquire timestamps based on the input signal provided in the timer channel of the microcontroller STM32F446RE by configuring the particular channel in input capture mode. Let's get started. So the input capture module is a tricky module. So this particular input capture module is widely useful in measurement of frequency of pulses, time period of pulses, and also the pulse length in various applications based on your application needs. We will be directly reading the timestamps of the timers using the input capture module, and based on the timestamps then we will further write down our logic for building your application, whether it could be a frequency measurement system or a time period measurement system or a pulse measurement system or a time between two events. You can write and build your own logic based on the timestamp that you are reading using the timer input capture module. So as the first preliminary step, I am just going to show you how you can read the timestamp using the timer input capture module or timer channel configured in input capture mode. And further, if you want to build your application based on this, you just want to write down your own logic for building the same. So let's get started with the process. So I hope you watched the previous video in the same playlist of this course of bare metal programming in STM32F4 series microcontrollers. So in that video, I hope you learned the basic functionality of timer input capture mode and the importance of this mode in timers, and particularly this video is based on the previous one of our video which we already did, that is in the video of generating pulses of predefined or required frequency using timer output compare mode. We have written a program to generate pulses of 500 millihertz using the timers configured in output compare mode. So we are just going to take that program and we are going to alter that program, or we are just going to add the feature of input capture to it for demonstrating the input capture functionality in the hardware. So I'm just opening the project that we have created in the lecture of generating pulses of required frequency using timer output compare mode lecture. So this is the project that I have created in the video that I mentioned before. I'm just opening the project created in Keil Microvision 5. I hope you are expertised in creating the project steps in Keil Microvision IDE for the microcontroller of STM32F446RE. I have already taught you several times in the previous video. If you have any queries in that, please go back to any one of my videos so that you will learn step-by-step process of creating the project in Keil Microvision 5 for this particular microcontroller. So this is the program that I have written in that lecture. For an overview, I am just going to tell you what is happening here, or what is the configuration that has been done in this particular program. So the above configuration in the program is doing this particular thing, that is the PA5 channel or the PA5 pin of the STM32F446RE is configured in output compare mode of timer 2. So this PA5 is timer 2 channel 1, and this timer 2 channel 1 is configured in output compare mode for generating pulses of 500 millihertz. 500 millihertz in the sense is nothing but 1 second on and 1 second off. So total time period of the pulse generated is 2 seconds, and it will turn on the pin for 1 second and it will turn off the pin for another second. So the main purpose of choosing this particular PA5 pin is that in our Nucleo F446RE development board, we have an onboard LD2 LED which will help us to demonstrate the output in the hardware. So that is why we have chosen this particular PA5 pin, and we configured this particular pin in timer 2 channel 1 output compare mode for generating pulses of 500 millihertz. So this is what is happening. This particular configuration right over here. What are all the things that we have done right over here will generate pulses of 500 millihertz. That is 1 second on and 1 second off in the channel PA5. So we are not going to disturb this particular portion. We are just going to add the configuration below right over here so that we will read the timestamp output, so that we will use the output signal that is being generated using the configuration done right over here in the input capture channel. So we will be connecting this particular PA5 pin to the input compare pin that we are going to configure right over here, and we are going to get the timestamp information from the output of the timer output compare module. So let's just open the datasheet and Nucleo user manual for finding a suitable pin for acquiring the timestamp using input capture module. And I have just now decided to use another timer, not this particular timer 2. So let's take timer 3 for now for configuring in input capture mode. I'm just opening the user manual, or I'm just opening the datasheet, and in the table of contents just move to the alternate functionality table right over here. So let me choose a suitable pin for this. PAPB, wait a minute. So all right, now you can see the port A table right over here, and I have chosen the particular pin of PA6 right over here. So in this table you can clearly see the PA6 has these many types of configurations that can be done. It can be configured as TIM1 BKIN, TIM3 channel 1, TIM8 BKIN, SPI1 MISO, I2C, I2S2 MCK, TIM13 channel 1, and DCMI PIXCLK. So these are the possible alternate functionalities for this particular PA6 pin. So I am just going to configure this particular PA6 in timer 3 channel 1. That is the alternate functionality 2 for this particular PA6 will be used for configuring the PA6 in timer 3 channel 1. So I am just going to configure this particular PA6 as timer 3 channel 1. So I have chosen the particular timer input capture pin here to be PA6 input capture channel. So I have chosen the input capture channel as PA6, and the alternate functionality that you need to configure for this particular PA6 is AF2. And for doing this, as usual, I have derived these many steps that you need to perform for configuring this particular PA6 in timer input capture mode. So first step is we just want to enable the alternate functionality mode for the PA6 channel. As you did right over here, we have enabled the alternate function mode select for PA5. We just want to do the same for PA6. So before that, we just want to enable the clock for the GPIOA, and this has been already done right over here. You can clearly see the clock for GPIOA is enabled right over here. So you need not do this again. If you are going from here, you want to do this also right over here. So now I am proceeding with these steps. That is enough for configuring this particular timer 3 channel 1, that is PA6 in input capture mode, for receiving the external pulses to capture the timestamps. Here I am just going to open the user manual, and I am going to GPIO registers and mode R register. You can see this particular register is having 2 bits allocated for each pin. That is 0 and 1 is useful for configuring PA0, and similarly 30 and 31 is useful for configuring PA15. So in our case we just want to configure PA6, so we just want to use bit number 12 and 13 for configuring that particular pin in a particular mode. So the 4 different combinations of modes that can be done is input, output, alternate function mode and analog. So if you write 00 to these 2 bits, the PA6 will be configured as input, 01 will configure the PA6 as output, and 10 in these 2 bits will configure the PA6 in alternate function mode, and setting these 2 bits will configure the PA6 in analog mode. So in our case we just want to configure this particular pin in alternate function mode for choosing the alternate function of timer 3 channel 1. So I am just going to set the bit number 13 and I am going to clear the bit number 12. That is, I am just writing 1 and 0 to these 2 bits. So I am just going to use the same GPIO pointer and I am going to point to mode R, and I am going to set to the bit number 13, and I am just going to use the same GPIO pointer for pointing to mode R, and here now I am just going to clear the bit number 12. So now we have successfully selected the alternate functionality mode for the pin PA6, and the next step we just want to set the alternate functionality mode of the PA6 to timer 3 channel 1. So as we already fetched some details from the datasheet of the microcontroller, that is AF2 configuration of PA6 will configure the PA6 in timer 3 channel 1. So that we already fetched the detail from datasheet. You can see timer 3 channel 1 of PA6 is nothing but alternate functionality 2. So now moving to the particular register called alternate functionality register of the user manual inside the GPIO chapter, I am just going to alternate functionality low register. So this particular register is having 4 bits allocated for each channel. So if you are configuring bit numbers from 0 to 3, it will configure the configuration or alternate functionality for PA0. Similarly, it goes on 1, 2, 3. And since we are going to configure for PA6, we just want to use bits from 24 to 27. So we just want to configure this particular channel in AF2, that is alternate function 2. So we just want to write 0010 for configuring the particular channel in AF2. So we just want to write this 0010 to bit numbers from 27 to 24. So we just want to clear bit number 27, 26, 24, and we want to set the bit number 25. So I'm just doing that. GPIO AFR. So since we are configuring the alternate function low register, we are just using the buffer value of 0. Okay, and if you are configuring the alternate function high register, you just want to use the buffer value of 1 right over here. So since we are going to configure a low register, I am just using buffer of 0. So here I am just going to set to the bit number 25, and I am clearing the bit number 27, 26, 24. That's it. And the next step is we just want to enable the clock for timer 3. So before finding the register inside the RCC, the shortcut that we are usually following is we will be just opening the data sheet and we will be opening the block diagram as we discussed earlier. So this is the block diagram that you can find in the page number 16 of the data sheet, and here you can see the timer 3 right over here. The timer 3 right over here is connected to APB1 bus. So this timer 3 is connected to APB1 bus. So in the RCC register, you can move to the register of APB1 ENR. APB1 ENR. If you move to this particular register, you can clearly see we are having timer 2, timer 1, timer 4, etc. So for enabling the clock of this particular timer 3, you just want to set the bit number 1 of this register. So this is the shortcut for finding the respective bus of the peripheral of the microcontroller for enabling the clock. So here I am just going to use the pointer RCC and I am going to point to APB1 ENR and I am going to set to the bit number 1. And the next step is we just want to set the prescaler for timer 3. So as we did the prescaler here, right over here, we have just run the timer at 1000 Hz frequency. But here we are just going to set the same prescaler in the same methodology, but with a different factor. So prescaler is just a division factor which is useful for setting the frequency of the timer at which it runs. So here I am just going to set the prescaler of timer 3 using tin3 variable and I am going to set the prescaler to be 1600 so that my timer will run at 16 megahertz divided by 1600 is nothing but 10,000 hertz. So here the timer 3 runs at 10,000 hertz and timer 2 runs at 1000 hertz. So this is the difference. So here we are capturing the timestamp and here we are running the timer for generating the pulses using timer output compare mode. And here the channel for the timer needs to be set in input capture mode. So moving to the timers chapter of the user manual, general purpose timers. I am moving to the register of capture compare mode register CCMR1 and going to the bit number 0 and 1. So here you can see if I write 00 to these two bits, it means it is configured as output. So for output compare mode, we just want to clear these two bits. And if I write 01, it will configure it in input capture mode. 10 also configures the channel in input capture mode. Only difference is this will map it to TI1, this will be mapped to TI2. There is no much difference. You can configure any one of these. So I am just going to configure this in input capture mode of TI1. So I am just setting the bit number 0 and clearing the bit number 1. I have set the TIM1 bit number 0 CC MR1 and I am clearing the bit number 1. And next we just want to set the polarity of the input capture module, that is at which event the capturing of timer input capture must occur. That is, it can occur at rising edge, falling edge, and also at each edge of rising and falling. So that mode of selection of capturing the time events needs to be selected. So I am just going to the register of CCER. CCER. Let me move to that particular register. That is timer capture or compare enable register. And here you can clearly see there is a bit number 0 which needs to be enabled for enabling the timer configured as input. So for input configuration also this needs to be enabled, for output configuration also this needs to be enabled. So I am just setting this particular bit tim3 CCER or equal to of 0. So we enable the timer in input capture mode, and further for selecting the pulses you may need to come right over here. You can clearly see CC1P bit number 1. When it is 0 it is configured as active high in output compare, and when it is 1 it is configured as active low in output mode. So in the same register you can clearly see there are other bits, bit number 3 and bit number 1. So these two bits clubbed together is useful for configuring the capture event configuration. So if you set value of these two bits to be 00 as here, it will capture the time events only at rising edge of the timer channel. And if you configure the value of these two to be 01, it will configure the timer channel in inverted mode so that only at falling edge the timer stamp events will be recorded, or the timer input capture events will be occurring only at falling edge. So you can configure any one of these. I am just going to configure in rising edge. So whenever a rising edge from low to high pulse is given at the timer 3 channel 1, that is at PA6, I just want the timer event to occur, that is timer input capture event to occur, so that I can record the timestamp at that moment. So here I am just going to tim3 CCER. I am just going to clear the bit number 1, bit number 1 and bit number 3. Bit number 3. And next thing is I just want to enable the timer. So as you did here, you just want to do the same for timer 3. So only changes, I just want to change this to timer 3. That's it. We have completed the configuration of timer 3. That is the configuration for PA6 to be configured in timer 3 channel 1. So we configured successfully the PA6 pin of the microcontroller as timer 3 channel 1 for capturing the input signals using input capture mode. So whenever a rising edge is seen in PA6 pin of the microcontroller, the timer event will be triggered, and using that event we can just do anything based on that. So here we are just going to capture the timer count value at that particular moment. So for that we have a particular flag for monitoring that. So move to the timer SR register, that is nothing but the status flag register. So that is available right over here, timer SR. So where is that? Oh, here is this. So here you can clearly see this particular register is useful for monitoring the timer states. So the bit number 0 of this particular register is nothing but UIF, which is nothing but the flag which will be raised whenever a update event occurs. So we configure the timer 3 in input capture mode. So whenever a rising edge is seen in the input capture mode, that is to the PA6, which is configured in timer 3 channel 1, this particular flag will be set. So we are just going to use this particular flag for capturing the timestamp or the timer count value of timer 3 at that moment. So I am writing like this. You can clearly see I'm just waiting until the edge is captured, that is until rising edge is captured, and once it is captured, this bit number 0 will be high and this condition will fail and this loop will be exited. And here I am just writing timestamp or the timer count value is equal to tim3 CCR1. So the CCR1 is nothing but the count value of timer. I will show you that also. So this CCR1 is the capture compare register. So this will hold the data that you want to load. So once it is configured as input, the CCR1 is the counter value transferred by the last input capture event. So you just want to read this particular register instead of timer count register directly. So we just want to declare this particular variable. So since we are not updating and the machine is updating this particular variable, it is safe that you just configure it as volatile type. I'm initializing this particular variable to be having the value 0. You can clearly see this is the program. So after all these configurations, it will come inside the while of 1 and it will wait until the timer event occurs. Once the timer event occurs, it will exit this particular line number 55 and it will come right over here and it will load the timer stamp value at that moment to the timestamp variable. So we will be visualizing that in the debug viewer window after a few moments. So now the hardware connections that I'm going to make is here in this program we have already configured the timer to channel 1, that is PA5 pin of the microcontroller in timer to channel 1 for generating pulses of 500 millihertz. That is the PA5 pin is already configured in timer to channel 1 and it is generating pulses of 500 millihertz. That is, it will be toggling its state for exactly 1 second. That is 1 second it will be on and for another second it will be off. Again 1 second it will be on and another second it will be off. So that pulse generation is already done in the PA5 channel configured in timer to channel 1 in output compare mode. And below we have configured the timer 3 channel 1. That is, here we have configured the PA6 of the nuclear development board of the STM32F446RE in input capture mode for capturing the timestamps from the external inputs. So I will be connecting the PA5 pin of the microcontroller with the PA6 pin so that the pulse generated from PA5 will be directly fed to the PA6 pin. So for every 1 second the input capture event occurs. So whenever a rising edge occurs at the PA6, this particular input capture event occurs and the timestamp will be loaded with the new value at that moment. So the PA5 will be generating the pulses for every 1 second, and the PA6 will be capturing the time at that moment, and it will be storing it to the timestamp. So this is a way of demonstrating the timer input capture. So that is why I am using the same configuration that is done in the output compare program also. I am just compiling this program. You can clearly see the compilation is successful with 0 errors and 0 warnings. I am just loading the program. I have already connected my nuclear development board with the PC through mini USB cable. You can clearly see the ST-Link debugger is connected. Just choose that, and you can see the IDE is also there. So no issue with the connection. I am just dumping the program using the icon right over here, or you can also use the F8 in the keyboard for dumping the flash. The flash has been successfully loaded. Now I am just opening the. Here you can see this is the connection that I have made. I have taken a jumper of yellow color and I have connected it to the D13 and D12 pin of the Nucleo F446RE development board. So D13 pin is nothing but PA5 of the STM32F446RE, and D12 is nothing but the PA6 of the STM32F446RE microcontroller. So that the PA5 which is generating so that the pulse generated from the PA5 will be directly transmitted and loaded to the PA6 for reading via input capture module. Let's visualize the output in the debug window. Debug viewer window. Double click on this timestamp and right click and hover over this add timestamp to and click on watch 1. Right click on this timestamp and click on the hexadecimal display for unchecking this, so that you can view the value of the timestamp in decimal values. Now I am running the program. I have already connected my PA6 pin of the microcontroller to PA5 pin, so that the pulse generated from PA5 will be directly fed to PA6 of the microcontroller, so that for every 2 seconds exactly the input capture event occurs and the timestamp will be loaded with a new value. So here you can see for every 2 seconds, whenever it is receiving a high rising edge, whenever the PA6 is receiving the rising edge, the timestamp is loaded with the new value. So PA5 is generating the pulse of 500 millihertz, and the PA6 is capturing the pulse and it is loading the timestamp variable with the new value. So this is how you can capture the timestamp of the timer using timer input capture mode, and you can further use this particular timestamp for calculating the frequency of pulses and also for calculating the duration of pulses, etc. So based on your application needs, you can use this particular input capture module of the microcontroller and you can implement in your project. So I hope you learned something new in this video. See you in the next video. Thanks for watching.